show you after. It's recording right now.
I have to pick on my sunglasses because my prescription are being repaired.
Can you say that?
With these on, I can, yeah.
Okay, good.
Okay. Is this most of your students?
2, 4, 6, 12, 14, yes it is.
Okay. So, my name is David Connors, Dave Connors. I am an adjunct faculty for the Water Environment and Technology program, the WET program, which basically prepares students to go into either the water or the wastewater industry. By that I mean most communities have some form of drinking water preparation before it's served to the general population. So in a lot of cases that includes, in Michigan there's a lot of surface water, so a water plant might take the water, filter it, disinfect it, and then distribute it to the water mains and houses that you live in, that kind of thing. On the other end of it, which is what I'm more interested in, I'll be talking about more, is the wastewater treatment plants. A couple new guests here. Come on in, have a seat. My specialty is really in the wastewater treatment end of things. Most communities, by the order of the DEQ, have to reach a certain level of cleanliness before their wastewater is allowed to be discharged into local receiving streams. In Michigan, there's, like I said, a lot of surface water, so let's say the city of Saginaw, for instance, has a wastewater treatment plant that collects all the sanitary waste and commercial, residential, industrial waste that's discharged into a sewer. They collect all that wastewater stream and they treat it in various forms, and I'll talk about some of that as we go. So operators work at those facilities and they're in charge of making sure that the water is treated properly before it's actually discharged to, in the case of the city of Saginaw, the Saginaw River, which is part of the greater watershed in our area. So there are a couple of students here who have taken my class before. You took my class too? Yeah, I thought so. I forget some of the names because students come and go. I'm sorry about that. But Matt, right? Matt over here took my class in the winter. He's already employed in this field. He is a drinking water operator up at East Tawas at their Lake, Huron Shores Regional Utilities Authority plant. They take Lake Huron water, they make drinking water out of it, and they distribute it through East Tawas and Tawas, surrounding area somewhere in there.
And Oscoda, yeah.
Up north to Oscoda as well. So he's already employed. I think 4 of his classmates, him including and 3 others, were employed before the semester even ended, and that was a beginner wastewater treatment class. So the demand for operators is great, let's put it that way. I have been in this business, it'll be 29 years next week. I have 1 week of unemployment in my life, and that's because when you leave the military and go into, when you leave the military, they consider you being fired. Even though I got an honorable discharge, they consider it a firing. So I was already hired before I got out of the Air Force to be a drinking water plant operator. It's what I did in the military. I kind of got stuck in this, as I say. It's another job in the military that you can do, and I don't know, maybe I got lucky, maybe I fell into some poo, I don't know how you want to put that, but either way, I've been doing it ever since. So that's kind of my background. I have a few slides I wanted to go through and share with you guys, and hopefully we can ask some questions. I tend to talk fast, so feel free to slow me down, ask a question. You wet students, I expect you to chip in here a little bit and make it clear what we're about. So, like I said, I joined the Air Force. I got a lot of on-the-job experience in this field, actually working at a wastewater plant at an Air Force base. We also did some drinking water treatment, so that was part of my experience. I took some college classes. There's some self-study courses, some correspondence courses you can take for this field. I also took some of those. I worked at a plant that I was an operator at. We also did some maintenance. I did some laboratory work, so I actually went into the lab, did some analysis to test the water for certain parameters that are set up by the DEQ. You guys all have heard of temperature and pH and chlorine levels. There are other things related to it that are more technically involved, like biochemical oxygen band test. There's a coliform analysis test. There's a suspended solids test as part of this. So you have to kind of learn about all these different tests and be able to perform them. Eventually, in this field, you become state certified. So much like if you were a welder of sorts, you would take a certification exam to see whether or not you're skilled at welding, right? So there's different kinds of welding. Same is true with wastewater treatment. There's different levels of classification. The certification is put on by the state of Michigan. So inside the DEQ, there's an office called the Operator Certification and Training Unit. And they give out an exam twice a year, and you go with your pencil and your calculator, and you fill out a test form, and you see if you're smart enough to be able to be a certified operator. So these guys that are in my program, or in the web program, you're in the program, right? Or you're not in the program anymore. These 4 characters along the back are still in the program, I believe. When they graduate from Delta and do their practicum, the practicum is where they go out into the real world and actually work alongside an operator at a plant, get some hands-on experience. They will be able to take their lowest level wastewater certification. So it's called the D exam. So the D exam is a lowest level. It's got a bunch of wastewatery stuff on it, some math, and if you're any good at it, you pass the test, you get a D certification. So from there you can go up to the C, the B, and the A. The A certification requires some college credit, requires a bunch of supervisory experience, or they call it something a little different, but it's basically showing that you've operated a plant and you've been in responsible charge of the facility enough that you had to make decisions about the operation of the plant. So I am a Class A operator, which means I took the test and passed it, and it was really hard, and thank goodness that's over with. So every 3 years or so, you have to demonstrate that you've taken some courses or some workshops or classes that continues your education. So in the big game of life, there's something called continuing education units or credits, depending on your career field. Nursing is a common one where you have to continually take some kind of training to show that you're keeping up with the latest in the business, so to speak. So every 3 years, I have to resubmit an application, show that I took some courses that demonstrate that I still know what's going on in the real world of actual wastewater treatment. So I did some. I worked at a plant for a while. After that, I worked for a company that makes wastewater treatment plant equipment. There's a company here in town, in the city of Saginaw. I don't know where all you are from, but in the city of Saginaw, there's a company that makes wastewater and water treatment plant equipment and ships it around the world. So they have an office down M13 on Leon Scott a little bit. I used to work for them. I traveled all around the country, somewhat in Canada, and started up new equipment. So these are large metal objects made of stainless steel worth hundreds of thousands of dollars that come with control panels and motors and little gizmos and gadgets. And I would fly around and teach people how to use the equipment, make sure it was installed properly, and let people know how to maintain it over its life. So I did that for a while. That provided a lot of experience for me. I met a lot of cool people. Eventually, I met somebody who has their own rep firm. So you guys know what a pharmaceutical rep is. They go around, they talk to doctors, and they try to talk them into using certain medications, right? You guys have all heard of that, I'm sure. You're not living under a rock or anything. In this business, there is a similar type person, maybe hopefully a little less. There's kind of a stigma attached to a pharmaceutical rep. Isn't there a bit of a stigma to that, So in this business, I'm a salesman now. So I have 40 lines of equipment. I mentioned the company in Saginaw that makes equipment. It's a screening piece of equipment. It filters wastewater. There is a lot of different manufacturers of this kinds of equipment. So I represent 40 different manufacturers who make all kinds of different treatment process treatment type equipment. So I try to find plants or engineers or projects where they can use my equipment, explain to them how the equipment works, let them see what the benefits are of my equipment, and eventually try to get them to buy something, basically is what I'm trying to do. So I have the best stuff, so why would they want to buy from me, right? Like that's kind of what I have to go with, right? So, all that led to me being part of the faculty, adjunct faculty here because of my experience in the business, and I know a little bit about wastewater treatment. I teach basic wastewater treatment and advanced wastewater treatment here at Delta College. And there's some other adjunct that do the water side of things, like drinking water. You'll probably hear from one of them if you haven't already. There's a hydraulics class. That gentleman is part of the DEQ's engineering department. He knows a lot about hydraulics and how that works. What are some of the other classes you guys have taken? I'm drawing a blank on some. There's a management class. There's an electrical component. There's a maintenance component. So all the people that teach those classes are people that actually work in the industry, and they're doing this kind of like a little side thing to help train up operators and, kind of give back to the industry, maybe make a couple of bucks. I'm not going to get rich being an adjunct faculty, but it's not a freebie either. Today's a freebie. I got a cup though. I got a mug or something. So today's kind of a freebie. So I do this little thing because I believe in this industry. I think water is a really valuable resource. Obviously, that's an understatement. Michigan has 74% or so of North America's fresh water. I think there's a statistic like 95% of the fresh water is locked up in the polar ice caps. The Great Lakes has 2% of the rest of the fresh water. So kind of give you some perspective of how much water we are really in charge of here, or have an impact on in the great scheme of things in the globe, right? So this is an industry where you don't hear about it quite a bit. Some of you may be hearing about this for the first time. You may have never even heard of such a thing as a wastewater treatment plant operator. I never did. I joined the Air Force, never heard of it before, read the description and started crying. I did not want to treat wastewater. This sounds disgusting. I don't want a part of it. But in the end, it's actually also a pretty cool business too. So, once you know somebody who's kind of in the business, most of the general population doesn't hear about what we do. You hear about policemen and firemen and those kind of guys who do construction. They build houses or plumbers, that kind of thing. You hear about those things because it's part of your everyday life. You kind of flush the toilet, you kind of forget about it. You don't even you don't want to think about it anymore. I get it, I hear you. I don't want to think about it much either, but I'm in the business, so I think about it all the time. That's what I do. So, so these are some of the jobs that are part of that, this career field. This little pamphlet, I don't want you to absorb in your pamphlet yet. I'll describe it a little bit, but it has a listing of some of these things. Plant operator is kind of the basic job that we're all being trained for in this program, this Water Environment Technology program. You could be also a specialized maintenance worker in this business, somebody who understands the type of equipment that we use. Some people are just in the lab all the time. Some plants have these three jobs as part of one person's role in the plant. I worked at a plant where I did operations for a week, I did maintenance for a week, I did lab for a week, I did something called rounds. Most of these plants have outlying facilities that need to be checked on a routine basis. So, a person gets in the truck. There's plenty of males, females, all sorts of people that are in this business. But they get in the truck, they drive around the community, they check different stations, make sure they're operating properly. So that was a 1 week thing. You did it all week. Another thing was like a fill-in person. There's 5 little sections we all had. We kind of rotated regularly in these different sections, so you got a lot of experience that way. But in some larger facilities, the city of Saginaw comes to mind, the laboratory people that work in the lab, the technicians, that's all they do is the laboratory portion. So that's in the bigger plants, that's kind of the way it is. It kind of keeps, you heard the saying, too many cooks in the kitchen spoil the soup. The laboratory is kind of like that. If you get too many hands in there, it can disrupt the way the laboratory data is coming out of the lab. So you kind of have to be kind of careful about, see Matt's over there shaking his head, or he's nodding because he knows, he works in the plant. Lab is probably pretty high up on the list of what's most important about my facility. I need good data to be able to run it properly. So it's good to have good lab technicians that know what they're doing in the lab. So Engineers, go ahead, Dave.
Dave, I was questioning about the people in the lab, are they on a shift as well, or is that just during the day?
So they're mostly not on a shift. And it depends on the facility. So I say that, but then I also want to say this. Detroit is the largest wastewater treatment plant. Well, it's the second largest in the world. You can believe that. Detroit, city of Detroit. Second largest wastewater treatment plant in the world. Brazil is the biggest. So LA is like third. So I say that to say this. They have somebody in the lab around the clock. Where in smaller facilities, you might come in during the day, run all your samples, the lab guy's going home at 3, 4, 5 p.m., whatever their shifts are. So you don't need to be there to make changes throughout the day because the plant, you kind of set it up for make a change or two during the day, maybe not even make a change. It's good for 24 hours. You don't have to make a bunch of changes throughout the night. But Detroit is treating so much water in such a small footprint, you're always adjusting things. You're always making changes to feed rates, whether it be oxygen or some kind of chemical or moving water from one tank to another or that kind of thing. You're always making changes. So they might have like shift work for actually laboratory operators as well. Which leads me to say some of these plants will also have shift work for their operators, and it might be a rotating shift. That's kind of one of the distasteful little things about this business. Sometimes a plant like the city of Saginaw might be big enough where they need 24-hour coverage, and so you may have to work like so many day shifts in a row. You guys know much about the shop and how they run things over there? Sometimes they do a swing shift, what they call a swing shift, where they work so many days, so many seconds, so many nights, and then repeat over and over again. Have you guys ever heard that kind of work before? It's kind of tough on the body, let's say. So some of the wastewater plants are set up like that so that nobody gets stuck on one shift all the time. They'll rotate around in a shift. They'll do like 7-day shifts and then have a couple days off and then do 7 afternoon shifts or 6 afternoon. There's a couple of different schemes out there, but basically it works out so you're always kind of moving and working a different shift. So people don't like to do that. So people will then maybe go, well, I'd just rather work like second shift all the time, and they'll like change their schedules, and it just depends on the facility and where you wind up. But a lot of the smaller plants, like City of Midland has a plant, they don't have to worry about doing this weird rotation thing. Bay City has 2 plants, Saginaw Township has a plant, City of Flint has a plant, Genesee County has a couple plants. So it depends on the size of the facility and how complicated the treatment process too. That's another kind of big factor in it. So I actually want to talk about some of that process stuff. I think it's interesting, and you guys are all in the science kind of field, I think, so you probably find it interesting as well, so I'll talk about that. So engineers, I work with a lot of engineers that design facilities. Either they're building new systems in that facility or they're rehabbing some old systems. So that's another angle in this profession you can work at. Engineers, I'm a sales agent, I guess. I call myself a rep or a sales engineer. Some people call us that. So we look at projects and we try to see what we might be able to get something that we represent on the project and make a little bit of money on it. Most of my work is commission work. So if I sell a big piece of equipment, I get a little chunk of the money from the equipment, basically. That's what it comes down to. So I mentioned manufacturers and then contractors. There's several contractors in this area. They specialize in this kind of work, working at wastewater and water treatment plants. That's all they do. They don't do like build a house on the side. They do this kind of industrial or commercial type work. It's really industrial work. So come on, baby, you can do it. We're all pulling for you. So these are some of the places they work. I mentioned municipal water, wastewater treatment plants. There's private companies that do it. Matt over here works for a company that is privately owned that runs a municipal water treatment facility and a wastewater treatment plant. So they it would look something like this. Like let's say the city of Saginaw has a budget of so many $1 million a year they spend to treat their wastewater. This private contractor comes in and goes to the city board and goes, hey, we can save you $1 million a year if you hire us to run it instead of having these, city employees. And so the city board votes on it, and they decide to go to a private contractor. And then the private contractor comes in and runs what is really a public facility. So that's a thing that winds up happening. There's several private contractors out here that do that kind of thing. So local, state, federal agencies, people like the DEQ. Dow Chemical has a couple of has their own wastewater treatment plant. They hire wastewater treatment plant operators to run their facility. That's another example. Equipment sales, that's what I do. Consulting firms, independent contractors. So we kind of hit some of those. So I'm not going to take a lot of time with the WET program. It's really important. Some people saw they needed it, so now we have it. It's good for all you because you get another opportunity. So these are some of the organizations associated with wastewater treatment. Some of them also deal with water treatment in the big scheme of things. This Water Environment Federation is a thing. They're the national kind of trade association. If you think about auto workers, what do you think of? Like, what's the national?
UAW.
Yeah, they're a union that stands up for the rights of workers, right? Like something like that. This is it's kind of like WEF is kind of like a clearinghouse for anything related to the wastewater industry that might be able to share knowledge with others in the business. So they have a trade show, they put on seminars, they have workshops. So underneath that is this Michigan Water Environment Association, which is what this pamphlet, or that's who has published this pamphlet. So this Water Resource Recovery Technician is a program put on by the Michigan Water Environment Association that does training for people in the field. They also hold seminars and workshops and that kind of thing for people to get together and discuss things that are ongoing in the field. There's all kinds of changes always happening. So these seminars and workshops are a place where people get to hear each other out and learn from one another about kind of what's going on in the field. This little pamphlet is really an advertisement for a program that the MWEA puts on, that if you take a certain number of these classes that are listed inside of here, you get a certificate of completion, which for an operator in a plant might be somewhat of a resume builder or an experience builder, so that they can show that they're cultivating their skills to be able to move up in this business, right? So, and there's some other ones there. The American Water, AWWA, you guys probably heard of them before, their drinking water side of the business. Water is important, yeah, we got that. So, really, the desire for wastewater treatment really increased with the, you guys have heard of the Clean Water Act, the Surface Water Act. That was an act of Congress, literally, where it mandated that all wastewater treatment plants must have this secondary treatment process along with what they were already doing in their wastewater plants. Used to be a really simple thing where you brought wastewater into a facility, you settled out the solids that would settle, and then you discharged the water, a little bit of chlorine. Really rudimentary like treatment process. So this Clean Water Act said, no, that's not good enough. We got to do a little bit more than just this little settle the solids thing, right? So I'm going to talk about what exactly that looks like. It's basically a biological portion of treatment. So we actually use microorganisms cultivated in a tank that consume these solids that have come into the wastewater plant, which there's a whole lot going on inside that little paragraph right there, but can only get so deep in this. So I'm going to pique your interest, and you're going to join my program, and you're all going to be employed for the rest of your lives. That's the goal here.
I do hope that last part is true.
What's that?
I do hope that last part is true.
It will be true if you choose this program. And you show up to work dressed appropriately. That's pretty much what I tell people. 75% of being employed is showing up on time dressed appropriately. Make no mistake about it. That's half the battle. It's 75% of the battle. People are dying for workers. So Safe Drinking Water Act, it's basically part of this Clean Water Act, but it's the drinking water side of it. So one is for wastewater, one is for, one is for wastewater, one is for drinking water. So this is the 8th grade hydrologic cycle. There's only so much water, we have to keep it clean. If anybody's visited a river or a stream nearby here, you'll see that it's probably a little polluted. My job, people in this industry's job, is to keep that from being worse than it already is, right? Anybody ever been up north and been to a crystal clear looking stream or brook and think, that's amazing? That's the goal. That's what we're trying to do, is keep this pollution out of the water. So this is what a wastewater, can you get maybe the first switch, Matt, behind your head there, so you can see this picture a little better? Maybe get the other one. So this is an overhead view of a wastewater treatment plant, a WWTP. So a wastewater treatment plant is a plant that receives wastewater from around its area, and it treats the water that's coming to it. So there's some large circles, you see the large circles, there's a building or two, there's some square tanks. This is typical of what a wastewater treatment plant might look from the air, what might look like from the air. The City of Saginaw plant looks a little bit like this. So there's a lot of stuff going on in there, but that's basically what it looks like. It's a really cool facility that treats wastewater. Usually it kind of smells bad. So it's wastewater, you expect. So here's a bigger one. I think this is like the city of Dallas or something. These round tanks are called clarifiers. They've got a bunch of rectangular looking tanks that are divided into cells. Each one of these things does a certain thing. My portion, I'm trying to sell one of these tanks. That's my goal, to try to sell some tank or some piece of equipment next to it that does something inside the tank or inside the plant. Another one. So this is a left to right, what I would call a process flow diagram of what happens in a wastewater plant. On the left it says bar screen. A bar screen is a device that removes the toilet paper, condoms, and tampons that get flushed down the drain. Simple as that. It's where the goldfish and the money hang out. If you ever want to find out where it is, that's where it's going to be. The next stage in this little block diagram is a grit chamber. So after screening is usually grit removal. So any sand, silt, or clay that winds up coming down the pipe, we try to collect into a grit chamber. That's the first big 2 stages there. So that prepares the wastewater for treatment. The next little block is something that says primary clarifier there. If you can't read it, it's a little fuzzy. A primary clarifier is basically one of these round tanks. Let's see if I can go back. One of these round tanks there, it says in the bottom left, it shows it pointing in the middle there. It says secondary clarifier. Let's pretend for a minute it's a primary clarifier. It's basically a large tank that allows the water to slow down and hang out for a couple of hours. Wastewater or solids that are in the wastewater that are heavy will settle to the bottom of the tank. The lighter stuff, those the grease you washed off your pan and went down the drain, winds up in this tank floating as scum on the top of the tank. So they call that FOG, fats, oils, and greases. There's a skimmer arm that comes around every now and then, skims it off, puts it in a trough. It gets either put into a landfill or shoved into another tank where it can be consumed as energy by bacteria, and which would make gas out of it. So that's what's going on in that tank. So that's primary clarifier. So at that point, that's 50% of treatment. Just those 3 stages. They're all physical processes, right? So I remove some screenings, I remove some grit, I remove the heavy and the heavy solids and the light solids. 50% done. So the hard part is coming. So the rest of these solids that are left are suspended in the wastewater column. They're dissolved solids. They're broken down or so small that they can't settle. They can't float. They're entrained in the water. So in order to remove those, I always use the old cup of water. Can I use your? So you can see that her Powerade has some liquid in it. It's colored, right? So if you had sugar in here and you took a thing of sugar and you swirled it around, the sugar would be dissolved. You wouldn't be able to see the sugar anymore, right? So if I run this water or wastewater through a tank that is full of microorganisms that are cultivated for this purpose, they can consume these sugars and the other solids that are in there. It's part of this water column, these dissolved solids that are in the water column. They consume this sugar, they multiply. I can actually filter those microorganisms out. They'll create a big enough flock, is the word I want to use here, that I can actually filter those guys out of the water, and they'll settle to the bottom of a tank if they consume enough of this organic material like sugar is. And what's left, what eventually is left is this clear water leaving the plant. Now there's a whole lot going on inside that paragraph as well, but that's kind of the basics of it. So I've done physical treatment, I've done biological treatment using these microorganisms. At the end of the plant, there's usually some form of disinfection. This green box at the end is disinfection. So disinfection in this business is destroying pathogens. Pathogenic bacteria are any bacteria that will cause disease. So if I add a little bit of chlorine into the water, I will kill any pathogenic bacteria. So that if I then try to reuse this water, you say, that's disgusting. Well, if I discharge from a wastewater plant into the river, and then later on down the river I have a boat and I'm going boating in the river or fishing in the river, I'm in contact with that water. So I'm reusing that water eventually, right? So I want to disinfect the wastewater so that I can reuse this water again. I don't cause disease to my general population. Does that make sense? Is that cool? All right. So that's what that's all about. So left to right, that's kind of the basics of wastewater treatment. A bunch of processes put together in a row that eventually, most of these plants are removing, I would say 95 to 99% of the contaminants that come into the wastewater plant, they're removing to that level. While there are some hiccups every now and then, and you watch the news or read the newspaper, you'll see stories about our local facilities, whether it's Bay County, Saginaw, Midland, that have upsets or discharges that are beyond their parameters, and there's things that may happen to them like fines and regulatory actions, but for the most part they do a really good job of removing most of the pollutants and cleaning up the wastewater stream, so that's good. Wastewater is 99.9% water. The 0.1% that you smell is just that, 0.1%. So all these big facilities, all these billions of dollars that we spend is to clean this 0.1% out of the waste stream. It only takes a little bit to kind of, what I say earlier, spoil the soup, except in this case it's water. So there's lots of different kinds of plants. Most of them are similar in the idea of the way they work, but they're all a little different in how they actually operate. So it takes some technically skilled people to be able to run them. All right, Matt, what's this stand for? One of you wet guys ought to be able to get this one.
National Pollutant Discharge Elimination System.
Look at that, they're trained. Look at that, 1 or 2 classes and they're trained. So this permit is something that is issued by the DEQ in the state of Michigan. It's basically, it's a regulatory device that says to the plant owners, you're allowed to discharge this much of this much of that, this much of this. A temperature would be a good example. They might say your wastewater treatment or your wastewater must be above 40 degrees or below 100 degrees or something like that. Normally wastewater is somewhere around 50 or 60 degrees because it takes the temperature of the pipe that it's running through, and those are usually underground, so it's cool, it's not hot. But pH might be another one. It might say, the permit might say, your pH needs to be above 6.5, because if it's too low in pH, it would be too acidic. It might harm the fish, right? So nitrogen would be another one. If the stream that you discharge into is sensitive, it might say that the ammonia might have to be really low to protect the fish, because ammonia kills fish, right? So all these things are taken into consideration when they write up a permit and issue it to a municipality where there might be where there is an outfall. So that's that word in there. All these plants have an outfall. That's where the water actually falls into the receiving stream, or gets put into the river. So
Dave?
yes.
Another quick. Is that required at the wastewater treatment plant? What about the private chemical company? Do they have to go through the wastewater treatment plants, or can they get their own NPD?
So that's a good question. So he's asking about somebody like Dow that creates a lot of their own wastewater. They have their own wastewater treatment plant. They have their own permit because they're such a large facility. But there may be smaller chemical type plants or manufacturers or suppliers that have to do a certain amount of treatment to the wastewater, and then they dump it into the regular sewer. So that kind of depends on local sewer ordinances and the agreement that the city has with that manufacturer in their town or that kind of thing like that. Most of them do not have their own wastewater plant. They do a little bit of what we call pre-treatment and then discharge the water to regular, the sanitary drain or the sewer that goes to the wastewater treatment plant. So that's a good question. So they might have even that smaller manufacturer might have a specialist, like somebody like me or my 4 brilliant students in the back there who are in the program. They might have somebody like that on staff to deal with their environmental concerns. One of their roles might be to maintain this process that they have at that manufacturing facility to prepare the water for treatment and eventual discharge to the regular sewer. That was a whole lot of words. I hope I got that across. Does that make sense, everybody? All right. So this is what a basic, a community might look like as far as having sewers go. I teach things about different types of sewers, like sanitary sewers, storm sewers, combined sewer, which is basically those two sewers in one. So mostly nowadays, wastewater plants or wastewater communities try to separate their sewers so they have separate storm sewers, separate sanitary sewers, so that when it rains, all the rainwater doesn't go in the regular sewer and then flood the wastewater plant, which is really what is one of the major challenges that we face in this business is this sanitary drain here, where it's supposed to just have household waste, is inundated when it rains to the point where the wastewater plant can't keep up with the amount of water coming to it. It creates a hydraulic overload. If you heard the word hydraulic, it just means an excessive amount of water in one place at one time is the way I explain it. So if you've ever tried to pour 10 gallons of water into a 5-gallon bucket, that kind of gives you a visual of what it's like for some of these plants that are inundated with this water. Have you guys seen pictures of the hurricane from recent when these communities? That's a hydraulic overload situation for those communities. They have nowhere to pump all that water. It inundated the system so much that it just made a swimming pool out of their towns, basically, unfortunately.
Isn't that what happened when Midland flooded too last year?
Which time? I don't know about last year. I mean, yeah, they got a lot of rain in a short period of time, and that's what can happen.
Yeah, it flooded out all downtown and everything.
Oh, yeah, I don't know, is that down by the trades where that low-lying area is?
I mean, it was all over town.
Yeah, yeah, something like that. Too much water in one place at one time, basically. So plants, communities get involved in trying to separate these stormwater systems from these sanitary systems. So let's move on a little bit. So yeah, that's where the sanitary stuff comes from. That's what a sanitary manhole looks like. That's a storm sewer system. I'm kind of going a little faster here because I got about 15 minutes left and I got more cool stuff, and sewers are not going to be the end of my life here. So we're going to find some more cool stuff to talk about. So basically, if you separate the systems, you can keep the two waters separate and treat them separately. Stormwater doesn't have a lot of contaminants in it that we need to worry about. So we don't have to send it to the wastewater plant and waste all of our energy trying to treat what is pretty much not 99.9% water, but 99.99999% water, right? There's very little contaminants in it. The big issue with stormwater nowadays that people think about is, you drive your car down the road, oil drips off your engine, lands on the asphalt, it rains, the rain washes the oil off to the sewer. Well, if it doesn't go to the wastewater treatment plant, it's going to go to the river. So there's things on the road that the rainwater will pick up, in our yards. You think about if you ever sprayed for weeds in your yard, what is that? Roundup is a complicated chemical. The rain washes some of that into the sewer. So you can see where I'm going with all that, right? It does pick up contaminants. In the big scheme of things, it's little, but after a while, it all winds up in the river nearby. So that's another issue we're faced with, is like, how can we quickly treat stormwater in such a way that it protects our rivers, but we don't have to dump so much money into it. You guys are screaming about taxes already, and I don't have enough money to pay all them taxes. So how much infrastructure can I build and be effective? Does that make sense? Like, those are some of the challenges we face and talk about all the time. So she's lagging. There's things called lift stations. It's basically water from your house goes to the wastewater plant by gravity. At some point, you can only dig a hole so deep effectively, efficiently. So you put in a lift station, you collect the water in a little reservoir or basin, that's what's seen on the left. You raise it to a higher elevation so it can flow again by gravity. Operators and maintenance people that work in these plants maintain these things all the time, that's what they do. That's one of their jobs they might be tasked with. So read that banner really quick. This is a site I visited in a place called Wilkes-Barre, Pennsylvania. Oh, can you see that? I'm going in your way here. So, we treat wastewater in a cost-effective manner. I said earlier that most wastewater plants remove 95 to 99% of the pollutants for the most part, and maybe you're like, hey, what about the other 5 or 6%, whatever's left? Well, I could remove it all, but it's going to cost you, the general public, you, John Q. Public, it's going to cost you some money for that. So, like, I have to be cost-effective in my approach to wastewater treatment. I can't use all the city's money just to get that last 1% out, right? It would be effective cost-wise, so I can't do that and be responsible with my money, or your money. So this is what a bar stream looks like. So I wanted to get into a couple of the pictures of the actual pieces of equipment. This is wastewater channel. The wastewater is going through those bars. That's toilet paper he's scraping off of there. I think there's some orange peel there possibly. That could be a goldfish, I don't know. It's always a surprise when you go to the bar screen. You never know what you might find. He is standing on a metal plate that has holes in it. So when he scrapes up this debris, we'll call it, screenings, it will drip through that metal plate, and then it won't be so waterlogged when he tries to shovel it into that storage little garbage can behind him. Eventually that stuff is collected in a bigger dumpster and then dumped into a landfill. Now mostly nowadays these things are mechanically automated, like this. So the wastewater flows through the machine. These arms come around and scrape up those bars, bring it up to the top. In the very top where those arrows are, there's a mechanically dewatering device that squeezes the screenings, washes out some of the organics and the water, and then pushes it into a dumpster. So isn't that fascinating? Don't you guys want to work on that? Wouldn't that be fun? You're not convinced. Let me go further. So this is what a grit chamber might look like. This pipe right here is an air header. These little black things along the line there are diffusers. So they spit air out. The line is pressurized. The tank is typically full of water. All this is submerged in the water. Those air headers create a rolling action like this down the length of the tank. As the wastewater flows through it, it keeps the organics in suspension, but the grit is heavy enough to settle to the bottom of the tank. So when it settles, you see the black track along the bottom. That's basically stained from grit over the years of use. The grit settles in this area, and these little scraper things, these flights as we call them, scrape the grit to one end of the tank, and then a bucket comes down, picks the grit up, lets the water drain off it, and then dumps it into a container so that it can be disposed of through the landfill. So that's a grit collection device, an aerated grit chamber. The trick being those air headers rolling that water in such a way that the organics stay in suspension and the grit settles to the bottom of the tank. That's one strategy. I would call it, as a salesman who sells against it, semi-effective. But I do sell something like that, but that's unimportant right now. So this is a rectangular clarifier. I showed you a picture of the round ones. There's also rectangular ones. So the water is flowing in this direction through the tank. It's allowed to sit in here for, they say, you guys remember, how long is detention time?
2 to 4 hours.
2 to 4 hours. He's studying, he's keeping track. So proud. It's my proudest moment up here right now. So about 2 to 4 hours, the wastewater moves through the tank in such a way that it's forced to use the entire contents of the tank. It doesn't just blast through and then come out the other side. There's devices in place that prevents that. The scum is floating at the very top of the screen there. You can see this oily looking film here. That's the scum that's washed off all your pans and that you dumped down the drain because you did and it happened, and so what? Who cares? It's just us down at the other end trying to deal with it. You guys are not proud, man. So the heavy solids settle to the bottom. These scraper things push the grease. These flights push the grease down to there, make a turn down a sprocket, go to the floor, and then scrape the heavy debris down to one end. There's a pump down there in like a vault or a sump that pumps the sludge out. Every day the operator is in charge of pumping the sludge out of that clarifier to make sure that it doesn't start, it'll eventually float. The sludge would actually float to the top of the tank. It's a whole other, there's a lot going on in that conversation too that we don't have time to talk about. But that's the job of an operator. Make sure this tank is working correctly, making sure the flow through the tank is proper, make sure the sludge gets collected out of the tank properly, and then maintain all the systems in place that deal. There's a motor and a gearbox and these chain and scrapers and all that kind of stuff. So there's an empty one. Normally they're full when you're using them. So this is what an empty one looks like. This is a round one. You see the scum here. This is a little different than what I mentioned about fats, oils, and greases. This is a clarifier for another process, but basically the same idea. The skimmings are on the top. It scrapes it into a little scum trough, and then away it goes to the dumpster. So after that little like first couple physical phases, there's this biological phase. So there's a couple different ways. There's, I would say lots of different ways to do biological treatment. The main ones are this activated sludge and this some version of fixed film media. This is an activated sludge tank. In this tank is this brown looking liquor. We call it mixed liquor suspended solids. It has this foamy little look to it. You can see the water looks like it's kind of circling and moving around because it is. These metal pipes down the left-hand side of your screen with the blue stems, that's an air header. So at the bottom of that air header is the diffuser. The diffuser is basically a round device that has a membrane on it that spits little bubbles out because we're forcing air into this header, and these little holes in the diffuser makes little bubbles. It's as simple as that. So the microorganisms living in this tank need a certain amount of oxygen, and they need food. The food is the wastewater, the poo, if you would, in the wastewater, the organics. So that's their food. We give them some oxygen. They consume this food. They reproduce. Eventually, if left unchecked, they would reproduce in such a great rate that they would take over the entire plant and start discharging. So we have to waste some of those microorganisms out of the system. That's really the control mechanism for a plant like this, is to waste, continually waste. And that's where you're collecting these solids that they've consumed. Becomes part of that cellular structure that you can then remove from the system and safely get rid of. Where does all that poo go, you ask? That's a great question. We're going to find out. We don't have much time left, so if you have a question that is on your mind, you need to ask it quickly.
Jay?
Yes?
I had a question. What happens to all of the active bacteria and stuff? When you remove it, what do you
So
is it
that's what I was kind of getting at.
waste? Do you discharge it or do you?
So here's that activated sludge tank like this, a little process view. They consume the organics. They settle to the bottom of this tank. I waste some of them out of the tank eventually. And it says here it goes to waste sludge or to sludge treatment. So eventually I've collected a lot of this waste sludge. In Michigan, there's basically 4 ways to get rid of this excess waste sludge. So remember back in the plant a little bit, there was a primary treatment tank where whatever was heavy settled to the bottom. And now I have this biological sludge as well. So I have kind of 2 sludges there in a lot of cases. These sludges are collected and they need to eventually be dealt with. I have to get rid of them somehow, ultimately disposed of. So you can, in Michigan, you can burn it in like an incinerator. So most plants don't do that anymore. That's like the city of Detroit does that, the city of Flint does that a little bit. I think it's broken right now. And Ypsilanti, if you ever heard of that place down by Ann Arbor, they incinerate. Incineration is expensive. The advantages are it doesn't take up a lot of land, but the discharge, the air discharge is the real compliance issue nowadays, because we have the Air Quality Act as well. So if you don't have a scrubber on your incinerator stack, that's a problem. So most places have gotten away from incineration, and they've gone to this, what we call subsurface injection of biosolids. So I see some of you are writing, so I'll say that one again. It's a subsurface injection of biosolids. Basically, we can take this liquid sludge and we squirt it into the farm fields. So there's contractors, that's all they do. They go around from plant to plant, they take the sludge, they have this machine, they drive through the farm fields and they inject the sludge into the ground. Sounds gross, you say. Yeah, I say it does, but maybe it's better than burning it. So the advantages are it's got a lot of nutrients in it, right? So we remove nitrogen and phosphorus. It's a soil enhancer, so to bulk up the soil so that you can grow things on it, this stuff is actually good for that. The distinction is we don't grow crops on this that we then eat. We can feed, like we can grow feed corn for like cattle, they can eat it, but maybe we then eat the cow, but we didn't actually eat the corn. It was kind of a break in the chain there, right? So there's two. The other one is Detroit is now making fertilizer pellets. That's a thing. Milwaukee has been doing it for years. This product they call Milorganite, you may have seen it in the stores. It's human feces processed in such a way, made safe that we can actually touch it with our fingers and put it in our little crops in our yards. That's three, isn't it? What's the other one?
Landfill.
Oh, thank you. Yeah, they're paying attention. These guys are smart. Some places will squeeze the crap out of the water. Think about that one for a minute. There's machines, I sell them, that you can squeeze the water, you squeeze the sludge, the water comes out, and you wind up with like a cake. You don't eat the cake, but it's dry enough that it'll stack up in a dumpster, or like a dumpster, a container, whatever you want to call it. You can take it to the landfill, and the landfills will accept it as waste. So those are the four main ways that people get rid of sludge. So we have really kind of come to the end of we have like 1 minute. So these are some of the devices I was talking about. These are the air headers underneath at the bottom of the tank. That's what it looks like actually operating. It's going to go a little slow here, but so that's what this industry is about, treating wastewater. This little wastewater treatment stuff that I'm talking about, that's basically the basics of it. This is semi-locked up, but I know some of you have classes. I would stay all night and talk about this, as you can tell by the enthusiasm that I have for it, but we can't do that apparently, so.
Thank you, Dave.
Yeah.
Does anybody have any questions before Emily turns off the video? Is it video?
There's a couple of clarifier sections. Yeah, I think there was a video that was trapped in there or something. This is another treatment device. This is the fixed film media I mentioned. The organisms are actually growing on these rocks. And as the wastewater trickles over them, they consume the organics as the water goes by. They get thick, the film on the rocks sloughs off and then goes into a clarifier to be collected as sludge. That's another thing. That's another type of device, some lab tests. These are some laboratory suspended solids tests. Disinfection, chlorine and UV light are very common. That's a chlorine gas cylinder, I teach about that. That's a UV system. That's a UV system in operation. And I think I've come to the end of my presentation. So, there you go. Any questions? That's it. So make sure you take WET 112, that's my class.
Thank you, Matt.
And WET 210, that's the other one. Have a great day.
Thank you, Dave.
No problem.